let's say I'm given the cost. Let's say the cost function is 5x plus e to 2x. I just made it up. And if I'm asked to find marginal cost, what do I find? What do I do?
You find C prime.
Yes, this is the marginal cost. So one thing, just remember this is chapter 3, but this test includes chapter 2 as well, the exponential and log 2.1 through 2.3. Okay. So C prime will be 5 times 2, 5 plus 2 times e to 2x. If I'm asked to evaluate, I'll evaluate. So if the cost is in dollars and x is in units, what would be the marginal cost, let's say C prime of 10, measured in? Yes, dollars per unit. Good. Here's a question. Do we know how to find the max min on a closed interval? Do we know how to find a max min on a closed interval? Please say yes or no. Do we need an example?
We don't have an example.
Okay, so here's an example for any function. Let's say even this function, f of x, 5x plus e to 2x. Let's say the interval is 1, 4. All I have to do is find f prime, which I already have, 5 plus 2 e to 2x, set it equal to 0, and find critical numbers. And then study the behavior. So I have f prime of x, and I have f of x. This example will never be 0. If it's never 0, that's fine too. It may not have critical numbers. If it doesn't have critical numbers, I have to plug in 1 in the function and get the value here, because the derivative is always positive. This derivative is always positive, never 0, and never negative. So because of that, this will be the absolute minimum, and this will be the absolute maximum. If the derivative is always positive, the function is always increasing. At this end, it will be a minimum. So 5 plus e squared, I can determine it right away by putting in the calculator. If it has critical numbers, then I have to study the sign left and right. So in this case, we have 5 plus e to 2x, and it's, 5x. And I just evaluated at 1 and evaluated at 4, and I'm done. At this end is 12.9, and at the other end is 3001. And there is nothing else. This is the absolute minimum, this is the absolute maximum. If it has critical numbers, then I'll put them here, 1 or more, and study the sign. And then evaluate which one is the absolute max or the absolute min. I have to show the table. I have to show the sign of the first derivative. And I have to plug in any number that appears here that needs to be put here, of course the endpoints, and any critical number. And I have to find the values of the function at all those points. And then make a decision based on the sign of the derivative. Whether it's an absolute min, absolute max, whatever. That's all there is for max min on a closed interval. Let's see what else. Implicit differentiation, we just had an example. What about linearization? The marginals, we had an example. What about the linearization and differentials?
We go over
Yes.
example of that one.
Of which one?
We do both the linearization and differentials.
Yes, of course. Okay, let me find the page. You can choose the linearization, the marginals on page 341. Of course. 341. I would definitely look at all the PDF files that you have from lessons. Definitely at the solutions to each homework, all of them. They're all posted, except the one from that was due tonight, which I will post tomorrow. So any linearization, if you'd like to choose. And then we'll look at it.
No, 20.
Yes. Very good. So we have x cubed. So this was my page 4. Good, page 5. Good. So we want to look at 20. You said on page 341, and the function is x to the third. And we want to find L of x, of course, and it's a equals 4. Perfect. Good. So the definition for L of x is f of a plus f prime of a times x minus a. So f prime of x equals 3x squared. When I plug in 4 in here, I get 64. When I plug in 4 in here, I get 16 times 3, 48. 16 times 3. When I plug in a here, I get x minus 4. And that's the linearization. L of x, 64 plus 48 x minus 4. I have to solve. So L of x equals 48 times x minus plus 64, I think. So 48x minus 128. So this is the linearization of this function. In other words, this linear function approximates this one near 4. Part B. Use a linearization to approximate 3.9 to the third, which means x is 3.9. Okay, so L of 3.9. Good. L of 3.9 is 48 times 3.9 and minus 128. Good, so this is 59.2. I think the next question is find this using the calculator. Okay, fine. 3.9 to power 3. So f of 3.9 is 59.319. Okay, the next question. What is the difference between the approximation, which is 59.2, and the actual? So 59.2 minus 59.319. So the difference is tiny. So 59.2 minus the previous answer. So negative 0.119. That's it. So this was part C and this was part D. Sorry. Good. That's all you need to do with the linearization. Now, concerning differentials, let's take a look. Well, we did these problems together. I don't remember exactly which one. But that's where the marginals and differentials come into play in the same. Did we do the computing? The Crawford computer finds that its weekly profit, such and such. I don't remember. Did we do this with the laptops, 8 laptops? I think so. Didn't we?
Yeah, we already did that one.
I think so. Is there one that we did not do? Oh, I don't remember doing the suitcases. Let's look at the suitcases now. So 31 on page 342. So we have r of x equals 0.007 x cubed. Do you remember doing this? If we do, we can choose another. So what is the...
I don't remember doing this one.
Okay, excellent. So the current production is 26 per week. And they're asking us what is the current weekly revenue. Okay, fine. So it's R of 26. And it will be in dollars. Okay, let's continue. We're going to determine in a minute. How much would revenue increase if sales increase from 26 to 28? So in part B, I have to find R of 28 and then the difference. So this is delta R, which is R of 28 minus R of 26. We're going to determine that in a minute with a calculator. The final question here, I think it's the final. Is there something? Oh, no, there is another one. What is the marginal revenue when 26 are sold? Okay, so let's find R prime of X first of all. 0.021 X squared minus X plus 150. And then we have to find R prime of 26. Okay, let's calculate all these now. Okay, so in Y equals, not R equals, I have 0.007 X cubed, and then minus 0.5 X squared, and plus 150X. So I need to plug in 28 and 29. So always go back and highlight to make sure. Okay, so the first one is 3961.66, and I'm sorry, I meant 26 and 28. How did I come up with 29? Okay, 3685. And for 28, is 3961.66. Okay. Good. And this is in dollars. Okay. Now the difference. So the difference will be 3961.66 minus 3685. That's the actual difference. Okay. If you can give this to me faster than I can find it, that would be great. 3685. So the increase in revenue is to 76.77. Now I want to put in the graphing calculator the derivative, which is 0.021 x squared minus x and plus 150. And I need to look at the value at 26, which is this 138.20, and this is dollars per unit. Then what is the marginal revenue for 26? Fine. And then part D, use the answers from part A and C to estimate the revenue resulting from selling 27 per week. Okay, so remember that is dy, which is f prime of x dx. That's the definition of the approximate. We know that the delta y is approximately dy, but they want us to find dy. So f prime of x is this, evaluated at 26. The delta x, because they're asking us for x equals 27, means that delta dx is 1. So they want us to approximate the change in revenue for a minor change in x. What was the minor change in x? From 26 to 27. And that is the dx. That's 1. And f prime of x is f prime or r prime of 26. So dy, or if you want to call it dr, better. This is the general form. So now I have r because it's revenue. It's this and nothing else. Not per unit, because we multiply by dx and we simplify unit with unit. So dr is only in dollars. So if the production changes from 26 to 27, the approximate change in the revenue is $138.20. Anything else? Is this okay? Yes?
Is the DX one just because of the difference between 27 and 26?
Yes.
Just to make sure.
Yes, because the
Okay.
whole concept is 26. They're throwing at us the 27 as well, but that's an additional, it's a side issue. Now they're saying use what you learned so far. Use the answers from part A, which is R of 26, and C, which is R prime of 26, to estimate the revenue resulting from selling 27 per week instead of 26. But the estimate does not include R of 26. The estimate is dy. Now, if they want us to find f of x plus dx, this is a very important formula, which is approximately f of x plus f prime of x dx, which is absolutely the same with this. Then it's a different story. But this is the delta y, or delta f, which is approximately dy. This difference is here, and this is this. They're saying just estimate. They're not saying to add these two. They're saying to estimate. Now, let me just read one more time here. The revenue resulting from selling 27 suitcases per week. So they said to estimate the revenue. Okay, so this is the revenue for 27, which is approximately the revenue for 26 plus r prime of 26 times 1. They're not asking us to estimate the difference. They're specifying that they want us to estimate this. In that case, I have to use A, which is 3685, and add 138.20. It's because once they mentioned this, and I realized that they were really interested not in estimating the difference, but estimating the revenue for 27. Fine, if that's what they want. So 26 plus 1 is the revenue for 26, and dx is 1. So it's the sum of 3685 and 138.20. So it's 0.2, 3 and 1, 2 and 1, 8, 3. So the estimated revenue at 27 is this. The revenue at 26 plus the estimate of the difference. If they only want us to determine the difference or estimate the difference, which is this difference, the actual difference that they didn't ask 27 till now. So this is the actual difference. Then I would have just given the answer this. If they want us to estimate the revenue at 27, then I have to add these two quantities. So that was linearization and differentials. Okay, do you want to go back to chapter 2 a little bit?
Yeah, can we go back